Hi learners, it's PV Murthy, Associate Professor in CSE Data Science Department at Marri Laxman Reddy Institute of Technology and Management. Today we'll explore topic on the data structures, why the data structure is required in the computer science engineering, what is its requirement, what it covers. We'll explore the step by step each and everything. What is the why we required these data structures? This data structure is efficiently we required for efficient programming the computer science engineering, all implementations of the softwares. What is the data structure? Why we required? What is the definition of the data structures? It's a data structures is an efficient way of organizing and storing data so that it can be accessed and modified efficiently. Importance of this data structure is efficient data handling is key in building fast and reliable softwares. Wherever the fast and reliable softwares implementation is required, we use data structures there. So for example, we are having the different types of data structures like arrays, linked lists, stacks, queues, trees, graphs. Each serves as a unique purpose. Okay. Only thing is why we required these different types of data structures instead of just using arrays. That is the one of the main question. See, this data structures navigations, it represents a various way of adding the data, deleting the data, accessing the data, processing the data. These data structures can be classified as primitive data structures and non-primitive data structures mainly. So what is the meaning of these primitive data structures? The primitive data structures contains int, float, character, boolean, pointers, whereas nonlinear data structures can be classified as linear data structures and nonlinear data structures, where elements form a sequence like a line. It is called as the linear data structures. Right, in the linear data structures, the way the elements forms linearity, based on it, we can identify as arrays, linked lists, stacks, queues. Whereas elements are not in the sequential order, we call such data structures, or the example of the such data structures are trees and graphs. Now we'll see each and everything slowly, that what is the advantages and disadvantages of this arrays, and we'll compare these arrays with other data structures one by one. When come to the initial data structure, primary data structure, array. Array is nothing but a collection of elements stored at continuous memory locations, possibly the homogeneous elements. All these elements are accessed via an index. See, these all arrays we are having based on the index. It can be 0 to n minus 1. All these are called as array indexes. At each and every index, we are storing the various data items. Initially, all these elements maybe one by one using the array index, we can store anywhere. But problem is we need not follow a continuous order. It can be stored from the first location, or it can be stored at the last location, or it can be stored in the middle location. But how we can identify this, which locations are occupied with the valid elements and which locations are not occupied with the valid elements, or say empty locations? It is very difficult to track the sequential order of the elements we stored. Even first we can store at the last, second we can store at the starting, then we can store in the middle, we can store in any order using the index directly. So that is the reason this accessing or storing the data using the arrays can be at a O of 1. But this such type of data structures are efficient when the number of elements are small. The difficulty is it is a fixed size. Whether we are using the all the locations or not, we can't either shrink if you are not using, or we can't expand if you are demanding more number of elements. So we need to use only that more part of the memory locations whatever we declared as an array. That is one of the main problem. The first thing is we can't shrink or expand, or even we can't track in which order we stored the data elements, or even we can't say which elements are occupied with the valid elements, which elements are not valid elements. So for example, this 15 and 3, we are not stored till now any elements, but we don't know whether these two locations are containing any valid element or not, because all elements we treat, even that elements whatever the data whatever we stored in the array, it can be a garbage. That means the data is valid only, but we are not saved, we are not used, it is unknown data. That is the thing. So whenever we declared any particular array, we can create an array with the maximum size, and we can store whatever the data we want randomly directly in any location. So when come to the data structures, a more flexible way of the data structures we can use, say for example linked list. Using the linked list, we can create a flexible connections from one element to the other element. Say for example, here the linked list is a linear data structure where elements are not stored at continuous memory locations, but all are occupied valid sequence. Instead of each node contain data and pointer, instead it is containing valid data and pointer to the next nodes. Through valid data and pointer to the next node, we can maintain continuity. So that element can be created anywhere, but we can acquire as many number of elements as we want. We can connect one element with other element using the links. Through it, whenever the elements are not necessary, we can shrink that, or we can remove that particular element. Whenever we want to add any element, either at the starting or at the end or at the begin, wherever it is necessary, we can add elements. That is one of the advantage of the linked list when compared to the array. And also now we can identify which element are inserted first or which element are inserted last, whatever the valid sequence we want. We can create the valid sequence of elements using the linked list. So what are we are having the different types of linked lists. The types can be a singly linked list, or it can be doubly linked list, or it can be circular linked list. In the singly linked list means we can follow a sequence, or in the forward direction of the sequence, we can move first element to the last element. Whereas in the doubly linked list, like singly linked list, as we are moving into the forward direction, but in that doubly linked list, either we can move to the forward direction, or we can move to the backward direction. Only the difference between the array and these linked lists are, in the arrays directly we are moving to the required element using the index. Whereas in the linked list, we are following one first element to the second element to the third element in a particular sequence. We can't directly move the required location. Similarly, we are having the third type of linked list is circular linked list. In the previous two linked list, we can move first element to the last element. Once we are reaching the last element, we can't move directly to the first element. Whereas in the circular linked list, we can move to the last element and we can come back to the list element. So this is the difference between arrays and linked list. In the arrays, we can move for any element directly using the index, but we can't predict a specific order. Whereas in the linked list, we can maintain the specific order. Not only the specific order, as and when required, we can expand the number of locations. As and when is not necessary, we can delete the elements where it is not available in the arrays. That is the reason we call the stack as compile time memory allocation, whereas list we can identify as dynamic memory allocation. So using the dynamic memory allocation, we can get grip on the memory, whatever we created, whatever the data we are storing and we are accessing, right? So the advantage of the linked list is dynamic size. The number of locations can be grow and shrink as needed. The efficient insertion and deletion is possible. When in the linked list also, we can maintain at the starting location. If whenever you want, we can store the data at the with of one time. Even after finding the specific location, we can access that particular element with O of 1. But only thing is, in the worst case, if the finding the particular element, it can be anywhere in the list. Unlike arrays, we can't directly move based on the index, but one by one we need to search and we need to move to the last location. That the details we'll see in the coming class the slides. But the difficulty is that it maintains only sequential access only. We can't directly jump to the required location, cannot jump to index directly. More memory per element. It not only maintains the data, but we need to maintain the address to the next location also. Due to the pointers, using the pointers, due to the pointers, we require little bit more memory. But this little bit more memory, whatever we are using for pointers, is negligible when compared to the whatever the data we are maintaining as data part of the node. Okay, that is the reason linked list we can identify as better than array in terms of the memory uses. We are not only maintaining the data, but we are a negligible amount of memory we are using for maintaining the pointers which points to the next memory location. So now we'll move into a little bit more depth the concept of the linked list. Okay, a fundamental data structures in the computer science in maintaining the data dynamically. Unlike the static arrays which created at the compilation time, linked list offer dynamic flexibility, crucial for many applications. Here we need not maintain the huge amount of data to fixed. We can identify the memory as and when required. Okay, this data, how you are maintaining the required data as and when required is, we are creating nodes, and all these nodes are connected with pointers. What this means, the node is, a node is the basic amount of data we are storing in the memory. Each and every node contains a data part and a pointer or link to the address of the next node. So data part stores the required data value, and pointer stores or link stores the address of the next node. Say for example, here we are having the 4 nodes. The each and every these 4 nodes are A, B, C, D. That means A, B, C, D are required values as we are storing in the first 4 locations of the array. The A is in the array, the first address is identified by the base address, whereas in the linked list, the first node address is maintained using the head. This head is a special pointer. It is representing the starting location of the linked list. So each and every pointer address or link address is representing the next node address. That means the pointer in A represents address of B after A. So from A we can reach B through this next link address. Similarly, from B, the pointer whatever available in the B node's address, we can reach the C. Similarly, we can reach from C node to D node. But we need to remember the last node means there is no more node after this last node. The last node contains a special value called as null. Whenever that particular node, whenever we are traveling from first node to the last node, whenever we are reaching the null address, it indicates it is the last node of the linked list so that we can stop. So similarly, not only it can maintain the alphabets or any, but any data it can be maintained. It can be alphabet, it can be the numerical value. The numerical values also can be maintained like 10 initially, then 20, then 30. Finally, we are maintaining the null value. Here is a small code. We are indicating the Python implementation. This Python implementation is representing the class node. The class node is containing a data value and a next value, two values. While you are initializing, we are maintaining the data in the newly created node. Similarly, initially we create any node, the next value as none, then we can update the next value with any valid address, so that we can maintain, we can link to the first node, or we can link to the last node, or we can link to the any of the middle node. Okay. So unlike arrays, these lists are dynamic. That is the point we need to identify. No fixed size. Logically, we can implement linked list with infinite number of nodes, so that we can allow efficient insertions and deletions in the linked list. Whereas it is not possible in the arrays. Whenever we are deleting any particular element in the array, that particular array index location is empty, okay, or unknown value. We can't say that particular thing is having a valid or not, whether we are processed or utilize that particular value or not. But when maintaining the linked list, we can easily identify whether the particular data item in a link node or address location we processed or not. That is one of the main comparison between array and so in the linear list terminology, each linear nodes or linear items are maintained as nodes. Initial node is maintained with the head. Subsequent nodes are maintained with the data element and linked to the next node. Last node is maintained with the null value. So to efficiently understand the linked list, we need to identify the key terminologies and their components and structure. Each and every node contain a node, or each and every data item is represented with the help of a node. It is the basic building block of the dynamic data structure, or can call as the linked list, comprising data and pointer, and it contains a head pointer. The head pointer always represents first node address or starting point, okay, referencing to the first node in the list. We are also maintaining in a special pointer address called as null. It is indicating end of the list. Sometimes if the head is contains null, it indicates a empty list. So null can represent either an empty list, or it represents end of the list. And we are maintaining pointer. The pointer is always indicating address location of the next node or another node. It is just a memory address representing where the next data item is stored, or where the next data item is available, so that we can move from the previous node to the next node and can be linked them sequentially. Through these pointers, we can maintaining the sequentiality among the linked list. That is the reason we call as a linear data structures. Now we conclude with what type of linked lists, linear lists are available. Then we'll identify each, and we'll explore more for each and every linear list in the next lecture. The first linear lecture is the singly linked list. Nodes are connected in a single direction, allowing traveling only in the forward direction. Each node points exclusively to its successor only. We can't come back. All pointers exclusively pointing to its successor. Whereas in the second type of list is doubly linked list. nodes contains two pointers instead of single pointer like in the singly linked list. These two pointers both represents next node and previous node, enabling us bidirectional traversal. So that means we can move from the first node to the last node, from the last node to the first node, or in the forward direction or in the backward direction. Okay, this adds more flexibility, but it contains little bit small overhead. This is the forward direction link. This is the backward direction link. Through this forward direction link, we can move from first node to the last direction, last node, or backward link we can move from the last node to the first node, whereas in the single linked list we are having only link representing to the forward direction only. Now we have a special type of linked list called a circular linked list, where the last node instead of previously it contains only null value. This null value node is replaced with address of the first node, so that we can after reaching the last node directly we can come to the first node. This enables us searching or doing any operation anywhere in the list, even in the middle. So if you are starting in the middle, maybe we process the second of the nodes, maybe we unprocess the first of the nodes, but using the circular linked list as last node address is representing the first node address, even now we can process the previous nodes without restarting to the first node only. So this enables us efficient searching of the operations in both directions. In the coming classes, we'll see all the three types of this linked list. We'll explore exclusively and do the various operations, advantages and disadvantages or any other thing. Right. Thank you.